Hello. This is an update on the tail project. What you're seeing here is the new prototype of the control board. This is all the digital processing stuff. So I have 8 potentiometers here as dummy inputs, though the system is actually 16 channels in total. So I'm using two 8-switch serial controlled Max 335s, very nice chip, to multiplex the ADC on a Mega 328, which is more or less being used as an intelligent 8-bit ADC chip. But the difference is when it's called, it actually sends 16 words across to the main processor. The processor then rearranges the information and spits it out to my RAM. 64K total. It's currently doing 1024 samples per input, so 16K by 8-bit, so roughly a quarter of the total space available. This is just the more or less just chip select or device select, bus select, I guess you could call it, system, because everything's sitting on one 8-bit bus. This here is another 328. This is going to be used for motor control. At the moment I'm temporarily using it as a 2-channel digital to analog converter for debug and test purposes. And finally there's going to be one more 328 there that's going to be used for my lighting control, because this thing's going to be blinky as well. At the moment, what it's actually doing is spitting out the result of sending a sine wave into one of the inputs and then spitting out the output that's delayed by 1023 samples, feeding that output into another input, and then showing again that waveform delayed by 1023 samples. So I have it looped into itself, and I'm keeping track of 2 analog ins at the same time just to prove that they're actually separate and their inputs aren't getting jumbled together. That's working alright. But if I change the waveform on the function generator to, say, triangle, see it change on the top and then roughly a second later on the bottom. That's the buffering that's happening. So I've built like a, I guess it's like a delay pedal, I suppose you could call it, but the 16-channel one. So what it's actually going to do with this memory dump, this big map of 1 second of everything happening, is it'll be able to check for trends, for specific wave shapes, things like that, to measure the sensor output and determine how to move the tail. So be able to pick up walking gait and this and that. I'm going to be building all of that into this little board here, which I'm currently working on layouts. Haven't quite found what I'm happy with yet, but this is close. And then here I'm going to have a ribbon that connects these 2 boards, and this will be the analog side. So this will be able to sensor preamps, the envelope circuits, stuff like that. And then the output of this will drive the motor drivers down here. And I've used the same split layout with pieces of brass in between so the boards can actually flex. But still communicate with a piece of ribbon in the middle. And that's all going to move this thing, but with no controller. This is lame. I want to free up my hand. The other thing I'm fiddling with right now is the tail lacks encoders. because I have no idea where the hell it is. So what I'm going to do is build encoders and the supporting electronics for them inside the gearbox. I'm thinking of either, let's see if I can get something pointy here. I'm thinking of either putting holes in this gear and having my mouse sensors on either side, or I'll put a wheel, I'll put a wheel on this shaft right here in the middle. I have the sensors there and the supporting electronics on the other side. I haven't decided yet. I'm probably going to go with the wheel because it doesn't need to be very fine positioning, and this shaft still turns several times within the motion of the tail. This is these gearboxes just with the shell off. So with the shell there, it's already going to be in darkness anyway. It's optimal conditions to throw in an encoder. So we'll see how that does. Anyway, that's all for now. But this is looking promising. Very, very complicated, but promising. Later.